योगः कर्मसु कौशलम्.
I, Dr. Krunal Soni, would like to thank UGC Human Resource Department, Gujarat University, for giving me an opportunity to present my topic on data analysis using parametric and non-parametric tests in SPSS at second online refresher course in Commerce and Management. I would also like to thank the director of UGC HRDC Gujarat University, Dr. Jagdish Joshi, for giving me this opportunity to present my thoughts and knowledge in regards to research. As we all know that he is a very dynamic personality and he has taken many initiatives to take the faculty fraternity in the education sector at human resource development. And that is why the UGC HRDC Gujarat University is also flourishing like anything. And that is why Gujarat University HRDC has taken many initiatives to develop many e-contents for the development of faculties and professors in higher education commissions. And this contents has been developed for Knowledge Consortium Gujarat in 2020. UGC HRDC GU was funded by MHRD under RUSA grant of rupees 3.33 crores. It is one of the few HRDCs which have very fruitful and successfully organized the program under it. And that is why UGC HRDC has many collaborations with many good B schools and good institutions across the India like IIM Ahmedabad, SPIPA, IIT Delhi and Mumbai, JNU Delhi University, the Lal Bahadur Shastri National Academy of Administrations, and many more. And not only the collaborations with the national universities, but they have also the MOU with the international universities in UK and Canada. Right. So with this note, I will start my presentations on the topic of data analysis using parametric and non-parametric tests in SPSS. Right. So we all are from social science, right? And we all understand the importance of research in this today's scenario. And that is why we all are here today to understand the importance of research in social science, right? We are from diverse field, like we are in commerce or management, right? And many of you are performing your functions in marketing, finance, HR, specialization, and many more, right? So let's start with the presentation. So first is, if we think about it, then the types of data in research. We need to understand which kind of data in research are available, right? So basically, if I have to say, when we are going for any survey or any research for social science, right, we need to prepare some questionnaires, right? And this questionnaire consists few questions in the research, and we need to decide how to demonstrate this questionnaire properly in your research, because proper demonstration of your questionnaire is very important of your research. And believe me, the questionnaire that you are preparing for your research is the base of your entire research. This will define whether your thesis is going to be in a good category, whether your thesis is going to be an excellent category, or whether your thesis is going to be on a moderate category. Everything will be decided on your questionnaire that you are designing for your research. So questionnaire designing is very important part for your research. And that is why we need to understand the various types of data in the research. So basically, if I need to divide the entire data for the research, so I will divide into 4 categories. First is nominal data, second is ordinal data, third is interval data, and fourth is ratio data. So one by one, we need to understand what is nominal data, what is ordinal data, what is interval data, and what is ratio data. So let's try with the nominal scale data. So what is nominal scale data? So nominal scale data is basically non-numeric category that cannot be ranked or categorized quantitatively. What is the mean by quantitatively? That means these are the data which has no relation with the quantitative aspect. That means you cannot measure this data in quantitative form, right? Let's suppose if I am saying, what is your gender? So either the respondent will answer male or female. So can we measure these things in a quantitative manner? No, it is not possible, right? And that is why this kind of variables are exclusive and exhaustive, right? For example, if we are asking questions in our survey, what is your age? So what is your age? What is your gender? Right? So this is nominal skill data, right? I cannot say your age is this, then I will form the order. I cannot form the order. First you will be male and first will be female, right? So based on that, the gender and age will be categorized in nominal scale data. There are many more things which you can categorize for nominal scale data, right? I've just depicted one example, that is gender. Then second part is ordinal scale data. What is ordinal scale data? So ordinal scale data are exclusive category that are exclusive and exhaustive, but with a logical order. What is the meaning by logical order? So logical order means if I'll ask you, what is your annual income per year? What is the annual income for any respondent? Right? So the respondent will answer in such a way that first I need to divide the categories of income. First is, let's suppose there is one respondent who has a less than 3 lakhs of income, those who are in fresher category. Then if we are going with few experience, then it will be divided into rupees 3 lakh to 5 lakh rupees of category, right? And again, if we go in ahead, it will be divided into 5 lakh to 10 lakh rupees of category. And the fourth category is 10 lakh rupees or more, right? So this is a logical order, right? We have given some logics to the order, right? First is 3 lakh rupees, then it is till 5 lakh rupees, then it is 10 lakh rupees, and then we will cover more than 10 lakh rupees of respondent. So this is called the logical order of the income. Clear to all of you? Yes. So even if we are conducting research based on the Likert scale data, right? Likert scale data means we are asking to the respondent one statement to the respondent on particular topic. Let's suppose if you are going for the online banking survey. So you will ask to the surveyor in Ahmedabad that online banking provide the fastest banking facility to the clients. So the respondent, if agree, they will respond strongly agree. If they are not agree, they will respond either disagree or strongly disagree, right? But it should be in a categorized manner. It should be in a proper format, right? From strongly, disagree, neutral, agree, and strongly agree, right? So this is how we need to define the order for the survey. Then we have the interval data. What is interval data? So interval data is a measurement scale where data is grouped into categories with orderly and equal distance between the categories. There is always arbitrary 0 points. Let's suppose grade marking, right? अगर हम लोग CGPA की बात करें and based on the CGPA, if we need to allot the grades to the students, A grade, A plus grade, B plus grade, right? So we have some intervals of marks, right? If you achieve this interval, you will get this grade. If you achieve this interval, you will get this grade. So this is called interval data. And the fourth category is the ratio data, which is purely a numeric data. Basically, ratio data can be used for the secondary research, right? If you are going for any stock market research or something, so this kind of data can be useful for the research, right? So then before going to this data, I would like to show you one questionnaire, right? So that will be more useful to you. How to design the questionnaire and how to understand the various kinds of data in the research, right? So this is one sample questionnaire. I hope it is visible, right? So see that if I'm asking in the question based on, let's suppose first is gender. So gender could be either female or male. So could you say, is there any relation that male has relation with the gender? No. These both categories are independent category. Either the respondent should be male or either respondent should be female, right? So this kind of data is nominal data. Clear? Yes. But if I'm asking the annual income to the respondent, right? So I have to start first below rupees 5 lakh. Then I have to go to rupees 5 lakh to 10 lakh. Then I have to go 10 lakh to 15 lakh, 15 lakh to 20 lakh, and about 20 lakh. So this is what ordering form, right? 5 lakh, then 5 lakh to 10 lakh, 10 lakh to 15, 15 to 20, and rupees 20 or more, right? So this is ordering form, right? Ratio data will not basically cover into the survey, but if you want to cover the ratio data, you can ask age like this. So either the respondent can respond their age in the multiple answers, right? It should be 25, it should be 30. Then the age will be a ratio data, right? Otherwise, if you group the age, then age can also be converted into ordinal form of data. Clear? Yes. Fine. So then, so basically, I'll come to my topic. Basically the topic which is given to me is parametric and non-parametric test. So whenever you conduct the survey and once you have the responses in your hand, what you need to do first, you have to make the coding in the research. You have to make a coding in the Excel file, and this Excel file you need to take it into SPSS file, right? So based on the SPSS file, you have to conduct the research, right? So normality test is the first basic criteria, right? But before that, I will show you some demonstration on SPSS file, right? Yes, so this is SPSS file. Yes, can you see it on the screen? Yes, so see that there are two windows, data view and variable view, right? Data view and variable view. There is two options. If you want to inject data by copy and paste, so that is also possible. You can directly copy and paste your data over here also, right? You can just put your cursor over here and you can press Ctrl V. Your data will get paste. Another method is if you go into this option file, right? If you go into this option file, open, and if you go into the data, right? I repeat, file, open, and data, right? So the SPSS will ask you the base from where you want to take your data, right? So I have given my base, right? So if I select any of the file, so we need Excel file or CSV file for this, right? This is a ready-made file, so SPSS file we cannot take. We need to take the SPSS or Excel file or any other files, right? To upload, right? If the file type is not supporting, so you can change over here, right? So you see that response file, right? This is response file. So if I'll open this, I will get this file, right? Okay. So out of this, I need to perform the normality test. So normality test basically perform on the ordinal data, right? You can perform on ordinal data. Yes, yes. So let's go ahead with the normality test. So how to perform normality test first? Then we will understand the interpretation and everything, right? So if you go into analysis, under this descriptive statistics, under this you have to select the option called explore, right? Analysis, descriptive statistics, and explore, right? So if you go into this, right, so see that this is already selected. I'll again put back. Yes, so see this all data, right? It could be ratio data or it could be ordinal data also, right? So if I will transfer this data over here, right, then in statistics we don't have to do anything, so click continue. Then if you go into the plots, right, so you have to select this option, normality plots with test. You have to select this option, normality plots with test, and press continue. Then in option, you don't have to do anything, and in bootstrap you don't have to do anything. Simply press OK. You will get the results. If you simply press OK, you will get the results in output file. Your output file will automatically generate it once you press OK in your results, right? See that the result is loading over here, running examining, right? Always normality test will take some time to run the file, right? So yes, let's go into the output file, right? So the result is running, we will wait for it. So till that time, we will understand the basic things about normality test. So basically normality test is used to determine whether the sample data has been drawn from a normally distributed populations or not, right? And once your data proves the normality, the test that you need to apply is t-test and ANOVA test, right? So normality test basically defined by QQ plots and histogram. right? You can use the QQ plots and histogram in SPSS as well. And that is why the basic assumptions of the normality test is the distribution of sample means is normal, right? So if your data proves the normality, then the distribution of the data is proven normal, right? And in SPSS, basically we are using two tests, Kolmogorov-Smirnov test and Shapiro-Wilcoxon test. When to use these two tests, or whether you should be used simultaneously or both separately. So there is a criteria to use the Shapiro-Wilcoxon and Kolmogorov-Smirnov test. When your population size is very large, so basically in social science we are going more than 100 population. For us, the sample size is not an issue for us. So basically we have to select the result of Kolmogorov-Smirnov rather than the Shapiro-Wilcoxon test. Clear? Yes. So Kolmogorov-Smirnov test that you need to use, and the null hypothesis for the normality test is the data are normally distributed, and the alternate hypothesis for null hypothesis is data are not normally distributed. Now, when to when null hypothesis accepted or rejected, how to decide? So if your if your probability value is less than 0.05, is less than 0.05, right? So we can say that the probability value is falling under the rejection region, right? If you remember this normality bell curve shape, right? So this is negative side and this is positive side. This is minus 5% and this is plus 5% if we are taking 5% error level, right? So if our value is falling under this area, so these area are called rejection region. So rejection region means, right, this is positive negative side and this is positive side. So if our data is falling either in positive less than 0.05 or minus 0.05, both are rejection region. So if our data is falling under this, so we need to reject the null hypothesis. And that proves that the data are not normally distributed. If it is greater than 0.05, this proves that the data are normally distributed, right? So based on the SPSS result, I have pasted result over here. So there are two tests which is given by the SPSS. As you can see that Kolmogorov-Smirnov and Shapiro-Wilk test, right? So Kolmogorov-Smirnov and Shapiro-Wilk test, but our sample size is more than 50. So we have to go with this significance value. And you can see that all the significance value are 0.000, 0.000. So can we conclude that these are less than 0.05 and they are less than 0.05? That is why we are falling under the rejection region, and that is if we are falling under rejection region, so we have to reject the null hypothesis and we have to accept the alternate hypothesis, and the alternate hypothesis is data are not normally distributed. If these values are greater than 0.05, then you are falling under this region, which is called the acceptance region, So acceptance region means we are talking about the null hypothesis. So if your p-value is greater than 0.05, so your data proves the normality. So if your data proves the normality with having the Kolmogorov-Smirnov value greater than 0.05, you can use the parametric test. And if your data are not proving the normality, that means your p-value is less than 0.05, then you cannot use the normality test, but you have to go with the non-parametric test. Yes? Okay. So this is non-parametric and parametric test difference is clear. Okay. What is parametric test and what is non-parametric test? Now we need to understand. So as we have seen that the parametric test is basically when your data is proving the normality, right? So what is the normality that we have already seen, right? So basically normality is to determine whether the sample data has been drawn from a normally distributed population or not, right? So this is called the normality test, right? So based on the normality test, we need to perform that whether our research is going for the parametric test or whether our research is going for the non-parametric. For parametric test, there are various tests that you can apply through the SPSS software, and the non-parametric test, there are various also the authors, or you can say statisticians, who has given the non-parametric test. So if I have to divide the parametric test, so first we will start with the first parametric test, independent sample t-test, right? What is independent sample t-test? So basically, it is most single widely used test in statistics. The t-statistics is used more in the social science research when your data proves the normality, right? It is, although it is a very hard fact that in social science, it is very difficult to prove your data get normally distributed, right? Basically, normal distribution in social science is very difficult to achieve, but still, we cannot say the data will not achieve the normality. When your sample size is very small, it might be possible that you will achieve the normality. So based on the normality, we need to decide, and we will start with the first is independent sample t-test, and which is most single widely used test in statistics. What the t-test is examining. So t-test is used to compare the differences of the separate groups. What does it mean by separate groups? So separate group means both the groups are independent to each other. That means they don't have any interrelation among each other. They are not interconnected with each other. Right. And that is why this test can be used to explore the difference in naturally occurring groups. Naturally occurring group means it is pure natural research. It is purely extempore that we have collected the survey and we have collected the responses from the market, right? And that is why the independent t-test requires the dependent variable is approximately normally distributed within each group, right? So there are two kinds of variable, right? Dependent variable and independent variable. First of all, we need to understand the difference between two variables. What is dependent variable and what is independent variable? So the dependent variable definition is when any variable is dependent on other variable, this variable is called dependent variable, and any variable which is not dependent on any of the variable in the research and it is independent in itself, it is called independent variable, right? So to run the independent t-test, whenever we are checking the normality, it is assumption that your dependent variable is approximately normally distributed within each group. Then only you can test the independent sample t-test. Otherwise, you cannot go for independent sample t-test. For example, we may be interested in differences in the perception between the male and female toward the online banking facility, right? So we need to understand there are two kinds of variable which is associated with this statement, right? First is the gender preferences, right? The gender is either male or female. And second is their perception toward the online banking facility in Ahmedabad city. So based on this statement, we can definitely think that online banking facility is for all the consumer, whether you are male or female, right? So male and female are not getting affected by the perception of online banking consumer. But yes, the perception of online banking consumer is definitely get affected by the gender preferences, right? And that is what we are testing in social science research. We are testing the taste and preferences, perceptions, a belief of different consumers and customers in the market over different products and service industry to check their perception. And this perception is going to be varied depending upon the age, gender preference, educational background factor, and everything, right? Let's suppose if I am taking the another example for the online banking facility for the consumer. So depending upon the education qualification that the customer have, the facility usage is going to be different, because those who are highly qualified, those who can understand the terminology, the technicality of the online banking facility, they could be more associated with the online banking facility as compared to those who are not highly educated in the market, right? The same thing can be differed, right, from male to female. Might be the perception of male and female is also going to be different. So perception is going to be different, but perception does not lead to change in male and female respondent. So the male and female respondent are not dependent on any variable, and that is why they are independent variable. And the perception of the consumer towards the online banking facility has a certain relationship with the demographic factors or demographic profile of the consumer, and that is why they are called dependent variable. Clear to you? Yes. Right. So independent sample t-test. So there are two things which we need to understand in independent sample t-test, right? So there are things that hypothesis for Leibniz statistics and hypothesis for independent sample t-test. Once your data proves the normality, the second thing we need to do is we need to perform the hypothesis for Leibniz statistics. Leibniz statistics is for homogeneity of the variances, and that is why it is called equal variance assumed and equal variance are not assumed. Right? The logic for acceptance and rejection of the null hypothesis will remain same. There is no change in the null hypothesis. Right? I again repeat, if p value is less than 0.05, if p value is less than 0.05, then our research is falling under the rejection criteria, and we fail to accept the null hypothesis. We fail to accept the null hypothesis. So we are going to accept the alternative hypothesis, and we can say that equal variance are not assumed, right? Even if your data proves the normality, and even if the Leibniz statistics, if your data are not homogeneous, again you cannot perform the t-test, non-parametric test, independent sample t-test for your research. You have to go for the non-parametric one. Only if your data proves the homogeneity, then only you can go for the parametric test. Yes. So equal variance assumed and equal variance not assumed, right? So equal variance assumed. So equal variance assumed. Here is your significance level. If you can see that here is your significance level is 0.0000, which is fall under the 0.05 less than 0.05 category, right? So there are two assumption over here. You can see that equal variance assumed and equal variance not assumed. Yes. So can I say this is the result of null hypothesis, and this is the result of alternative hypothesis. So if your Leibniz statistics is 0.005, so you have to see the results of alternative hypothesis if you want to perform independent sample t-test further, right? So if your data has not proven the homogeneity, right? So this significance value you can check. And if your data has proven homogeneity, means your this significance level is greater than 0.05, then you have to see this result. But here your data result is 0.000, so you cannot see the equal variance assumed result. You have to go for the equal variance not assumed results. Yes, then you have to see the significance value for the this, right? So if based on the equal variance not assumed, we have seen that the significance level is 0.00, right? Again, it is less than 0.05. So for independent sample t-test, this is the hypothesis, right? What is the hypothesis? There is no significant difference between the population mean, right? So basically, independent sample t-test is going to identify the basic difference between the population mean in your research. And if you can see that the alternative hypothesis, there is significant difference between the population mean. So if you can see that, if you can see that in the results, your result is 0.005, 0, 0, 0 over here, but we have taken this value 0.000 as equal variance are not assumed. So it is falling under 0.05. So we have to reject the null hypothesis, and we can see that there is a significant difference among the population mean in this research. Right. Let's try the independent sample t-test in SPSS, how to perform. Yes. Okay. So this is the SPSS file, right? And basically perform the independent sample t-test. You should have only, right? So basically t-test is what we can say compares, t-test is compares T-test compares the mean of two different groups in order to determine whether there is satisfied evidence that the associated population means are significantly different or not, right? So if I'm saying over here in your variable in your data, if I'm picking up the gender category, so in gender category there are two categories. Either it could be male or either it could be female, right? Either it could be male or either it could be female, right? If I check another category, age. So under the age, as you can see that there are 6 categories, right? One is for up to 20 years, second is for 21 to 30 years, three is for 31 to 40 years, four is for 41 to 40, up to six, right? So as you can see that over in age, there are 6 categories. And in gender, there are only 2 categories. So the basic rule to apply the independent sample t-test is that you should have the two groups, right? And t-test is identify is there any population mean association among these two groups or not, right? And now we need to perform the t-test over here. You can go into the analyze, right? In analyze, you have to go into the compare means. You have to go into compare means, and over here you have to perform independent sample t-test. So this window will pop. This window will pop up. Right now, see this, and here to perform the t-test, we should have your dependent variable. So here you can see that the test variable and grouping variable, right? You can see that test variable and grouping variable. So your test variable should be a scale data. Your test variable should be a scale data. It should not be nominal or ordinal data to perform the independent sample t-test. That is the most important things that we need to understand, right? And then if I need to pick up, so this dependent variable is scale data and independent variable is the demographic profile, which have a two categories. I repeat, the grouping variable should be demographic variable, which have a two categories. So as you can see that group 1 and group 2 I have given, right? So I'll press continue, go into option, no need to change anything. Then if you can go into the bootstrap, no need to change anything, you can continue, right? So then you have to press OK. Then you have to press OK. So you will get the results. You will get the results, right? So if I go into these group statistics, so this is and mean, standard deviation, and standard error. This mean and standard deviation is given for the scale data by comparing male and female. That means how many males are considering motivational factor, how many females are considering motivational factor, right? So this is descriptive. But the main thing we need to understand over here is these different values, right? These different values. Now, first of all, if I have to consider this t-test, right? So t-test is the value, right? So mean difference. So as I told you, that first we need to check this significance value, Levene's test of equality of variance, right? This Levene's test for equality of variance. This value we need to check, significance value, right? So you need to find out, is there any value which is less than 0.05? So almost all the values are greater than 0.05. Yes. So these all are falling under the acceptance regions. And yes, our data follows the homogeneity, right? Yes or no? Null hypothesis is data follows the homogeneity. and all the p-values are greater than 0.05. So we accept the null hypothesis, and null hypothesis is data follows the homogeneity. So if your data follows the homogeneity, is it assumed that equal variance are assumed. So see that all the equal variance are clicked once I have clicked on one variable. So for all the equal variance assumed, you have to select this first value to find out is there any significant difference between population mean or not. Yes, and as you can see that all the p-values are greater than 0.05, right? That means all are falling under the acceptance region. And acceptance region means we have to accept the null hypothesis. We cannot reject the null hypothesis. And the null hypothesis for t-test is there is no significant difference between the population means. So that means that there is no significant difference for motivational factors for online banking among male and female categories of online banking consumer in Ahmedabad city. This is how you can conclude your result. There is no difference between male and female categories for motivational factors for using online banking facilities in Ahmedabad city, Gujarat state. This is how you can interpret your results. Clear? Yes. So this was a t-test. Now, so t-test is basically used for two grouping variables, right? Male and female, whatever it may be. Then we need to go for the another test, which is called one-way ANOVA. What is one-way ANOVA? So one-way ANOVA is the ratio of two mean square, right? And it compares the means of two or more independent groups. So in previous independent sample t-test, you can apply independent sample t-test only when you have the two variables in your independent category, right? Male and female. But if you have more than two categories, you have to come to the ANOVA test, which is called variance, right? Equality of variance, right? You cannot apply independent sample t-test. You have to come out with the one-way ANOVA, right? So it compares the means of two or more independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different, right? Again, associated population means, they are not saying two population mean. If there are two population mean, we need to go for independent sample t-test, but they are asking associated population means. It means there are more than population means are there, and that is why we need to shift from independent sample t-test to one-way ANOVA. And it is used when there is more than two groups of comparison, which I told you in the previous SPSS file. I have shown you the age factor. There were 6 categories in the age factor. So we cannot apply independent sample t-test. We have to come out with the one-way ANOVA, right? For example, education qualification. So there are various categories. One category is schooling, second category is graduation, third category is post-graduation, and fourth category is professional courses. So these are the 4 categories. So this is 4 categories, which is more than 2 categories. So we need to shift into one-way ANOVA test, right? So this is one bifurcation that when to use the ANOVA test, right? So for ANOVA test, you can see the here it is. You should have the categorical data and you should have the continuous data, right? Continuous means ratio scale data, right? Whether you have ratio or scale data, and you can see that the ratio scale data should be independent variable, right? Just like in independent sample t-test, we have put it in test variable. So again, for ANOVA also, you have to put this continuous ratio variable into the test variable, and categorical data, just like education qualification. So it was category, right? Schooling, graduation, post-graduation. So this categorical data will be a grouping variable, that is independent variable for your study, right? Yes. So let's perform the ANOVA test for you. How to perform in SPSS? Let me show you. Yes. So to perform the ANOVA test, again, you need to go into the analysis. Then you have to go into the compare means, and you have to select this option, one-way ANOVA. Repeat, analyze, compare means, and one-way ANOVA. As you can see that if I will take this age of consumer, so हमने already देखा था कि age of consumer, there are 6 categories. So you have to remember this 6 because you have to write in the ANOVA right? Category bifurcation you have to mention. So 6 categories. So in factor, I will include age and dependent list. As you can see that these are the ratio scale data. Yes. So now we need to go into the contrast. There is no change in contrast. So press continue. Then post hoc, right? You can prefer the Tucky test basically, right? Normally we perform Tucky test. Then in option, if you want these mean plots or homogeneity of variance, right? So if you want homogeneity of variance, you can go for it. If you want descriptive, you can go for it, right? So press continue and okay. Right? So the SPSS will give you the results of the ANOVA test. Yes. So first of all, test of homogeneity. Just like in independent sample t-test, here we also test the homogeneity. As you can see that all the significance values are greater than 0.05, right? All the significance values are greater than 0.05, right? So we are falling under the acceptance region. We are falling under the acceptance region. And that means we need to accept the null hypothesis, which assume that data are homogeneous, right? So again, data are homogeneous, right? Then you have to see the ANOVA table, right? So in ANOVA table, there are various values. So I will explain what does this value means. Okay, now let's understand the values of ANOVA, right? So basically, F test is, this is, we are talking about this value F, right? So this F statistics is basically the ratio of two mean square values. If H0 is accepted, F value close to 1, right? If H0 is accepted, you will find your F value nearest to the 1. So there is a rule that if your F value high, that means the variations among group more is more that you expected, right? Then we need to understand what does it mean square value. So basically mean square value is whether the factors are significant or not, that will be proved, right? And it should be obtained by dividing the sum of square by degree of freedom. So if you divide 4.909 divide by 5, you will get this 0.998 values in your research. And if your F value close to 1, your research is significant. Here you can see that your F value is not close to the 1. It is more than 1, right? It is way beyond the 1. So your research is not significant, right? That means here the p value is greater than 0.05, which means we are falling under the acceptance region, and we need to accept the null hypothesis that proves that there is no significant difference amongst these two, amongst the means of the variances, right? So here, if you see that here the third factor, user friendly factor, you can see the p value, it is 0.03, which is less than 0.05, which means we are falling under the rejection region, and we have to reject the null hypothesis and we have to accept the alternate. And alternate hypothesis for ANOVA test is there is a significant difference. So as you can see that among the various categories of the age group of the respondent for online banking, there is a significant difference among the perceptions towards the online banking for the factor of user friendliness, right? So this is a proven. So once you prove this 0.03, we need to see that particular things in post hoc test, right? There are motivational factors for online banking. Then you can see that the belief of factors on online banking. Then this is a user friendly banking, right? So I have taken these results into PDF. Let's understand. Right. So let's understand in the PDF, right? As we have already discussed the mean sum of square values, right? This F value, significance value. So we are talking about this value, 0.03 values, right? So for this 0.03 user friendly factor, you can see that there are various age group. So if I consider the first age group up to 20 years, right? If I consider first up to 20 years, so as you can see that up to 20 years has a relation with the rest of the age category, right? And individually you need to check the p values. So it doesn't mean that user friendly factor for online banking has significant difference among the various categories of age group, that has a significant difference with age, all the age group, right? That doesn't mean we need to go for the post hoc test to check for individual age group significant difference. So if we consider first category up to 20 years, so up to 20 years has only one category, that is above 60 years. As you can see that the value is 0, which is less than 0.05, which is less than 0.05. So they have the significant association with the age group of up to 20 years. If we go into 20 to 30 years of age group, again up above 60 years have a significant difference. That means 21 to 30 years of age group that have a perception about the user friendliness factors for online banking, that is a differ at the age group of 60, above 60 years. That means this up to 20 to 60 years all have almost the similar thinking, or you can say similar perception about the user friendliness of online banking. But if we reach to above 60 years, they have different perception about the online banking. This is what the analysis that you can derive. Now there is another test which is called paired sample t-test. Paired sample t-test basically used for the secondary data, right? So paired sample t-test basically used for secondary data, because under both the categories you should have the ratio or scale data, right? Without that you cannot perform. And basically paired sample t-test is used to see the scenario before and after situation. I'll give you one example for before and after situation. If I'll consider that the stock prices, what is the impact on Infosys stock prices before dividend announcement, and what is the impact that you have measured on the stock prices once the Infosys has announced the dividend in the market. So if you want to measure the impact of the dividend on the stock prices of the Infosys, we have to apply the paired sample t-test only when the data proves the normality. Only when the data proves the normality. If the data doesn't prove the normality, you cannot apply the paired sample t-test. You have to go for the non-parametric version of paired sample t-test that we will discuss later on. So the null hypothesis for the paired sample t-test is there is no significant difference between before and after vertical jumps due to training program. So here we have taken one example that what is the jump size when you have the sportsman before training, and what is the size of the jump when you give some training to the sportsman and you will measure the result after the training. So before training and after training result has been given and we are measuring the difference, right? So if we go into this, let me show you through the SPSS how to do it, right? So this is paired sample t-test file. You can see that player 1 before jump size and after jump size, right? Now we go into the analyze, compare means, and here you have to analyze, compare means, and here you have to go into the paired sample t-test, right? So here you can put the variables one by one. First, in variable 1 you can put before, don't need to put player number, and here you can put after, right? And in option, if you go into the option, we don't have to go anything in the option, right? So press OK and you will have the results in the output file. You can see that, right? So you got the mean value. If we see the paired sample statistics, you have the mean value for before jump and you have the mean value for after jump. Then number of samples that you have taken. So we have taken 20 players, standard deviations of them and standard errors of them, right? So paired sample correlation 0.05. So what is the assumption for null hypothesis? No correlation and there is a correlation. So definitely there is a correlation proven in this study because your p-value is less than 0.05, right? So your null hypothesis rejected, which is no correlation. But here the alternate is going to accept it. So there is a definite correlation in before jump and after jump for the training program. So now you can see the p-values, and p-values is also proving that. You can see that 0.04, 0.04, right, which is less than 0.05. right? So that proves that there is a definite relation in before jump price and after jump price. Clear? This is what our assumption here. Okay. Now we are going to summarize it, right? When to use which test. So summary of the different t-test. So difference between the set value and a variable, you need to apply one sample t-test. Difference between two individual independent groups, just like we have given example, male and female, you have to go for independent sample t-test. And when you are examining difference between two related measures before and after, that is repeated over time, or two related measures at one time, right? जैसे हमने बोला, if you want to measure the jump size before and after training program, right? Or in medical science, you can see that the diabetes level of the patient before giving medicine and after giving medicine. So if you want to measure this particular things in a ratio data, you have to apply the paired sample t-test when your data proves the normality. Yes, so now we are moving on to non-parametric test. So non-parametric test you can apply when your data does not prove the normality, right? So non-parametric test you can apply only when your data does not prove the normality. That means your data are having p-value less than 0.05. In normality, there is different assumption. The null hypothesis for normality is data are normally distributed, and alternate hypothesis is data are not normally distributed. So if you are getting your p-value less than 0.05, you have to reject your null hypothesis. And null hypothesis is data are normally distributed, but here we need to reject it. So data are not normally distributed. So instead of using parametric test, you have to use the non-parametric test for the research if your data does not prove the normality. So the alternate version for the independent sample t-test is Mann-Whitney u-test, right? So same, the concept will remain same. When you have the two groups, independent two groups, and your data proves the not normality, then you have to use Mann-Whitney u-test instead of independent sample t-test. Then you have to use Mann-Whitney u-test instead of independent sample t-test, right? And that is why it has been said it is the non-parametric version of two sample t-test, and it is used when the assumption of t-test are not met. So assumption of t-test are not met means the one assumption for t-test is the data should prove the normality, and it is interpreted as comparing the means between the two populations. So here you are comparing the medians of two population. In parametric, we were comparing means of two population. In non-parametric, Mann-Whitney u-test, which is the substitute of independent sample t-test, here we need to compare median instead of mean. So your hypothesis should consist the median rather than mean. Clear? Yes. So again, it is used to compare two unpaid groups, and to perform Mann-Whitney u-test, first rank all the values from low to high. So basically this test will give you the rank of all the variable from lower to top or whatever it may be, right? But which is more important? So you need to pay the more attention on the lowest median rank, right? Because these are the most significantly affected. How it is going to affect, I will see you. So there is no significant difference between the medians of two population, and there is significant difference between medians of two population. And this is the test statistics for the Mann-Whitney u-test. We will go quickly in the Mann-Whitney u-test in the SPSS file. So if you go to the analyze, if you go to the non-parametric test, analyze non-parametric test, legacy dialog box, and here you need to select two independent sample. Analyze non-parametric test, legacy dialog box, and here you need to select two independent sample. So as you can see that just like in parametric grouping variable, we need to see the gender, right? Because the Mann-Whitney u-test is a non-parametric version of independent sample t-test. So you should have two unrelated groups. So I have a gender. So I will click over here, and you can see that if the Mann-Whitney u-test is not clicked, then you have to click over here to perform Mann-Whitney u-test. Mostly it is by default selected because it is mostly widely used test for the non-parametric version of independent sample t-test. So here we need to define group 1 and second group is 2, right? So we have why this 1 and 2, that I'll show you. Okay, because we can see that यहाँ पर when we see the gender, for male it is 1 and 2 is for female, and that is why we are defining this group category 1 and 2. Yes, so now we will see the output part. See that यहाँ पर you can see that there is a sum of ranks. You can see that there is a sum of ranks. Clear? Yes. So what does this sum of rank represents? Right. So this sum of rank will be represent, but before that, first you need to check the test statistics. Right. You can have to check the Mann-Whitney EU test and asymptotic significance value. Right. And there is a significant relationship. I will give you one hint. If your Mann-Whitney U value is higher, right? Right. So if your Mann-Whitney U test is higher, your probability is going to be higher, right? And if your Mann-Whitney U test is going to be down, your probability is going to be down. How I show you? You can check the value of Mann-Whitney over here, 2501, and here it is 2782. So you check the probability value also. From 0.185, it has went up to 0.773. So there is a positive relationship between Mann-Whitney U test and p value. If your Mann-Whitney U test is high, your p value is also going to be high, right? So here, if you can see that the p value which is greater than 0.05, which means we have to reject the null hypothesis, and it proves that there is a significant difference among the medians value of the data. Clear? So this is what the Mann-Whitney U test. Let's go to the PPT, right? So now the next test that we need to see is Kruskal-Wallis test. Kruskal-Wallis test. So again, Kruskal-Wallis test, just like for independent sample t-test, the non-parametric version for independent sample t-test was the Mann-Whitney U test. The same way, if your data proves the not normality and you have more than 2 unrelated groups in your study, then you cannot apply one-way ANOVA because your data does not prove the normality, and in that case, you have to switch over to the Kruskal-Wallis test for your research, and that is why it is a non-parametric version of one-way ANOVA, and it is used to compare more than 2 populations in a completely randomized design. Just like in one-way ANOVA, we have seen the example of education, schooling, graduation, post-graduation, professional degrees, right? So there are more than 2 categories. So we need to go for the Kruskal-Wallis rather than one-way ANOVA in non-parametric version. And the basically Kruskal-Wallis sum of the rank of K sample to compare the distribution. It is the sum of the rank of K samples to compare the distribution. Clear? And you can see in the image, population means, right? 2 to 8, right? So population mean ranks are equal. So the population will cover the median value, and based on that, they will decide the ranks, right? Okay. Now, the hypothesis for Kruskal-Wallis, there is no significant difference between the mean rank of the groups, and there is a significant difference between the mean rank of the group, right? So whatever mean rank that we are finding over here, right, that we need to find out. Let's perform the first Kruskal-Wallis test in SPSS, and then we will see the results. So again, for performing Kruskal-Wallis, you need to go into analyze. You have to go into the non-parametric test. Under the non-parametric, you need to go to the legacy dialog box, and under the legacy dialog box, you need to select this option K independent samples. So if you go into this, you can see that age, right? So before going to this, you need to define how many categories are there in this age. So there are 6 categories, right? So I need to define over here, right? So first of all, I need to select this age of consumer. Then I will transfer it to the grouping variable like this. And then I need to define the range, the minimum range and maximum range. So minimum range starts with 1 and the maximum range starts with 6. Then I need to press continue, right? Then see that over here Kruskal-Wallis by default, right? So you don't have to be worried about it, right? And then you can press OK. You will have the results. So first is the rank table. You can see that where you have the mean ranks over here in this. You have the mean ranks over here, right? These are the mean ranks for different categories, right? So which mean rank is important, that we will see. And if we go below, we have the test statistics, right? So if you see that, we need to see first this value, significance value, because this will prove our hypothesis whether null is going to be accepted or null is going to be rejected, right? So if you see the value for the motivational factor for online banking is 0.225, which is greater than 0.05, which means that it is falling under acceptance region. So null hypothesis accepted, and there is no significant difference between the mean ranks for motivational factor. Same thing is for belief factor 0.289, which is greater than 0.05, and null is going to be accepted. So there is no significant difference. But here you can see that user-friendly factors for online banking 0.008, which is less than 0.05. So this value is falling under the rejection region, under the normal under the bell-shaped curve, right? So if it is falling under rejection region, we have to reject the null hypothesis, and instead of null hypothesis, we have to accept the alternate hypothesis. And alternate hypothesis is clearly proving that there is a significant difference between the mean ranks of these different categories of the population. Clear? So for user friendly, you have the definite significant difference. So whenever any significance value proves the significant difference in the mean rank table, you have to only see that value. Here user friendly factor has a significant value, so we'll go into the mean rank table and we go into user friendly factors. And under the user friendly factors, if we need to consider which age group is highly significantly affected. So if you remember in one way ANOVA, there was about 60 years age group, and here also it is proving that, because over here you have to select those age groups which have the less amount of mean rank. The factor which have the less amount of mean rank, these are highly affecting factors for this particular things, right? So you can conclude your study that there is a significant difference between the mean ranks of user friendly, and out of this above 60 years people are highly getting affected, right? These people are highly getting affected by the user friendly factor, means they have difference of opinion as compared to the other group of online banking consumer. That is what the conclusion that you can derive over here. Clear? Yes. Then so this is what the Krunal test, right? So this is what the assumption that we have derived, right? Krunal. Yes. Next is Wilcoxon sign rank test. Again, this is a non-parametric version of paired sample t-test. If your data does not prove the normality while applying the paired sample t-test, you can switch over your study to the Wilcoxon sign rank test, right? And it is a non-parametric version of paired sample t-test. Basically, it gives the comparison of average of two dependent samples, right? This particular test is giving comparison of average of two dependent samples, means there are no independent or dependent categories in this particular test. Both are dependent on each other. Before jump size, before training jump size, and after training jump size, right? So who is dependent on what? Both are dependent. Before has a relation with after, and after has a relation with before. Then only the comparison is possible. Otherwise, comparison is not possible. So Wilcoxon sign rank test is for the ratio data, non-parametric version for dependent samples only, right? This is what we need to understand. And the hypothesis for the Wilcoxon sign rank test is, the null hypothesis is average sign rank of two dependent sample is 0. We have to assume null hypothesis is the sign rank of two dependent sample is 0. That means there is no difference in the sign rank. Both are giving equal signs. That means there is no difference before and after situation. And alternate hypothesis is proving significancy, that before and after sign are not 0. right? Before and after sign ranks are not zero, means there is some variation in before situation or after situation. We don't know in which situation, but that we can prove it through the test, right? So let's go into the SPSS file to perform the Wilcoxon sign rank test, right? So this is your SPSS file. Under the SPSS file, you have to go into the analyze. Under the analyze, you have to go into the non-parametric. And under the non-parametric legacy dialog box, right? Under that, you have to go to the two related samples. You have to go into the two related samples, right? So this window will pop up, right? So here, okay, we cannot perform in this file. We need to go into the paired file. Yes, see that paired sample before and after situation. Same, analyze, non-parametric, legacy dialog box, and two related sample. Means both are dependent variable, right? I'll remove again and then proceed. So first I will check before vertical jump training, and then in second column I will put after vertical jumps. Clear? And here you can see that the Wilcoxon sign test is selected, right? We don't have to check the other options. You simply need to put OK. You will get the results in the output file. So as you can see that the output file for first is rank, and this is test statistics. If I need to understand this rank table, so you can see that whenever we are comparing before and after, so those who have a negative ranks have a mean 6 and total players are 3. Those who have the positive ranks, the total players are 13 and the mean rank for positive sign is 9.08. And sum of the rank here is 18 and here is 118. Those who have the ties in the rank before and after. So from the descriptive statistics only you can define whether there is a significant difference or not. So you have to see the ties table. We have a total 20 players and out of this only 4 players are tied. Rest 16 players have some changes in their jump size in before and after situation. So definitely when you go into your test statistics, your p-value is always less than 0.05, which proves there is a significant change in before and after jump size for training program. Right, there is a definite change in the jump size of the players before training and after training. This is what the conclusion that we can derive from the survey. Clear? So this is what the parametrics and non-parametric version if you are going for the social science research. Right, let me open the PPT and finally I need to conclude what exactly we have covered in our presentation. So this is what the summary tables for the parametric and non-parametric versions of test. So difference between the mean of two independent variable, you have to go for independent t-test in parametric version. You can see that two independent, you can see that two independent, you can see that two independent. You in parametric you can go for t-test, in non-parametric you can go for man by t. So first you need to check the normality of the data by Kolmogorov-Minro, yes, Shapiro-Wilcoxon. Basically we use Kolmogorov-Minro because we have more than 50 sample size in every social science research, so we'll go for the Kolmogorov-Minro. Then difference between the paired sample, right? We have seen that before and after. So if the data proves normality, you can go for paired sample t-test, and if not proved, you can go for Wilcoxon sign test. Difference between the means of 3+ independent group. Here there was 2 groups in the first one for t sample t-test, right? And here it is 3 and 3+. So for parametric, you can go for one-way ANOVA, and for non-parametric, you can go for Krunal, right? There are other variables, there are other tests is also there for secondary data, right? The few tests, if you want to go for the strength of a relationship between two continuous variable, right? Just like if you remember in paired sample t-test, we have checked the correlation. So you can go for Pearson correlation, but you should have the continuous variable, right? You should have the continuous variable, and you can, if non-parametric, then you can go for Spearman correlation. Clear? So this is parametric and non-parametric test to establish the relationship between the data, whether it is normally distributed or not normally distributed, right? Okay, so that is, these are the references that you can cover. There are few books, good books for the research, right? You can refer the Eckloff and Russell's The Design of Social Research, right? Research Methodology, Concept and Cases by Deepak Chawla and Nina Sondhi, Vikas publication. Research Methodology, C.R. Kothari, very nice book, very good book to understand the every aspects of the research. Then if you want to see the SPSS in a very detailed manner, so you can go for the Using SPSS in Research by Dr. Radha Mohan, Bookman, Delhi publication. Business Research Method, Cooper and Skindle, and Marketing Research by Nargunkar, right? So these are the few books that you can refer for your research, and these are the material links that I have posted over here for every test, and the interpretation and everything is given for your references that you can refer if anywhere you are stuck up. So thank you so much from my end. I hope this parametric, non-parametric test in social science research will help you to write more and more fruitful paper, which can be published in good repute journals like Scopus, ABDC, and UGC Care listed journals. With that, I'm ending my lecture over here. Thank you so much. If you have any questions, if you want to ask any questions, you can definitely ask.